This next calculation is a little challenging. It involves the Avogadro constant and moles. Now we looked at both of these on the previous page of our calculation license. We had questions up here for using Avogadro constant. Okay, where we use the number of moles multiplied by the Avogadro constant tells us the number of molecules. And we also used the moles equation was it was mass divided by the mass of one mole, or the relative formula mass of that substance. So in this calculation here, we're going to combine both of those calculations. So this one says here, both those formulas I should say, this question here says how many molecules are present in 23 grams of a sample of ethanol? Well, that's the ethanol. So the first thing we need to do to calculate the number of molecules is work out how many moles of ethanol we have. So we have to do moles equals mass divided by the mass of one mole, the formula mass of ethanol, if you like. So the formula mass of ethanol, that's made of 2 carbons, carbon plus carbon, plus 6 hydrogens, 5 there and 1 there, plus hydrogen 6 times. I'm just writing out like this. Because it's nice and easy to understand. I hope you don't have to do it in such a longhand way if you find it easier. And 1 oxygen. And oxygen. Right, so if we look at the periodic table will tell us the mass of carbon is 12, the relative atomic mass of carbon is 12, the relative atomic mass of hydrogen is 1, and the relative atomic mass of oxygen is 16. I probably should have put those in this, this question. Okay, so I've got carbon is 12, so 12 plus 12. Hydrogen is 1, so 6 ones. And oxygen is 16, out of 16 on the end. So 12 and 12 is 24, 6 ones make it 30, and that 16 there makes 46 in total. So the relative formula mass of ethanol is 46. That's the MR of ethanol is 46. Mass, we know mass because it has a unit after it in the question, 23 grams. So that therefore is going to be 23 divided by 46. Well, that's going to be a half a mole. We've got half a mole of ethanol. Okay, so if this question said, how many eggs do you have if you have half a dozen? You would do a half times 12 to say there are 6 eggs. So that's what we've got here. How many molecules are there? We've got half a mole, so, and we've got the Avogadro constant, which again I really should have written in this question. If you go back to the previous page, you will see the Avogadro constant. The Avogadro constant is always given for you, is 6.02 times 10 to the 23. So instead of a dozen, which is 12, we have the Avogadro constant. So we need the formula number of molecules equals moles multiplied by the Avogadro constant. Okay, the Avogadro constant is 6.02 times 10 to the 23. You're always given that. The number of moles we worked out here is a half, so a half times 6.02 times 10 to the 23. The most challenging thing is putting that into a calculator. Okay, the answer, I don't need a calculator for that, just a half 6.02, it's going to be 3.01. Okay, still going to have 23 zeros after it. I mean, if you half 600, you get 300. It's still got 2 zeros after it. So it's going to be times 10 to the 23. I've done that in my head. Now, don't recommend doing this in your head in the exam. So let's just put it into a calculator to prove that's the case. Let's make sure we see all the keys there. So we said it was 0.5. So to do that, 0.5 multiplied by 6.02, 6.02. Now this times 10 here, sorry, that times 10 there, that is not multiply. It's not that button. Do not press that button. It's this button down here. Okay, that button there. Press that. Times 10, now 23 equals answer. 3.01 times 10 to the 23. 3.01 times 10 to the 23. Okay, those calculations are tough. And because they're tough, the examiner seems to be putting them on these recent Edexcel papers to try and separate the grade 7s from the 8s from the 9s. Okay, so here is one such example. Calculate a number of moles in 0.11 grams of carbon dioxide. Okay, first thing we need to do, calculate number of moles. We've got, so moles equals mass over formula mass. Relative formula mass of carbon dioxide is 44. We're given that, we don't have to work it out. Mass, 0.11 grams, 0.11. Stick that in the calculator. Okay, and it is 0.11 divided by 44 equals 2.5 times 10 to the minus 3. 2.5 times 10 to the minus 3. That many moles. Okay, so if you've got 2 dozen eggs, how many eggs do you have? 2 times 12. 2 times 12. So we're going to take the number of moles. Okay, we're going to take moles, and we are going to multiply it by the constant, the Avogadro constant. Because if you've got 2 dozen eggs, how many eggs do you have? It's 2 times 12. 12 is the constant. A dozen is 12. That's the constant, Avogadro. Okay, we don't have a dozen, we have something far more difficult to get our heads around, but in reality, it's no harder than trying to get our heads around a dozen. So, how many moles? It was 2.5 times 10 to the minus 3, 2.5 times 10 to the minus 3, multiplied by the Avogadro constant, 6.02, times 10 to the 23. And that's why these are difficult questions, not because the concept's hard, although the concept is hard because the Avogadro constant is so massively big. It's just a number that's too big to appreciate. A dozen you can appreciate, you see. This is big. What makes this hard is actually the numbers are very large and we have to put those numbers in a calculator accurately. So entering this in the calculator is the difficult thing. So let's say we've got to put the 2.5 times 10 to the minus 3 in, okay? So 2.5, now not multiplied, that button there, times 10 to the x, times 10 to the x. Now it's this button for minus here now, okay? Not the subtract button. Minus 3, okay? And then we're going to multiply that by the Avogadro constant, 6.02 times 10 to the 23, multiplied by 6.02, 23, okay, equals 1.505 times 10 to the 21 equals 1.505 times 10 to the 21. And you start to congratulate yourself now because you're thinking, job well done, 3 marks. A lot of marks for that question. Okay, and only the super bright are going to get it. You can get these. Okay, but it did say 2 significant figures. Now, lots and lots of grade 8 candidates will not get a grade 9 by 1 mark, and they will often drop a mark here. 1.505 times 10 to the 21. 1.5 times 10 to the 21 is now 2 significant figures. Okay, so there's one such example. There's another example I have as well, which we'll have a look at. Because these are difficult questions. Let's have a quick look at this one. This is, I think, the 2018 exam paper. Calculate the mass in grams of a hydrogen atom, okay, using the data below. You're told the relative atomic mass of hydrogen is 1, okay, and we know the Avogadro constant is 6.02 times 10 to the 23, and we're told that. What that basically means, the Avogadro constant there, is if you have that many hydrogen atoms, okay, if you have that many hydrogen atoms, you have 1 gram of hydrogen. So therefore, 1 gram is made up of that many atoms. So 1 hydrogen atom is going to divide, is going to be that much of a fraction. We're going to divide by the Avogadro constant to get the mass of 1 atom. Okay? So that's the simple, that's the maths we have to do. And stick it into a calculator. It's going to be 1 divided by 6.02, that button, 23, equals 1.66 times 10 to the minus 24 grams. 1.66 times 10 to the minus 24 grams. Okay, difficult question.